This is another example of a double sideband modulation. So we have a carrier signal C of t, and we have a message signal M of t, and so the question is to find the frequency domain. So basically, once we find the time domain, then we can use the Fourier transform to find the frequency domain. So still going to page 204, your x of t is going to be a times your message signal times your carrier signal. So m of t and your carrier signal is cosine of 2 pi fct basically. Of course, we're gonna multiply that over there. Now we just replace our m of t by our sinc function that's given over there on top. So m of t is sinc t plus sinc squared t now times cosine of 2 pi fct. Okay, so from here we can use a Fourier table to find our Fourier transform of x of t. So x of f, now here we have sinc of t times cosine 2 pi fct. We can use the table. That's a multiplication by cosine, so it's a modulation. So we're gonna have 1/2 x f minus f0. We don't have an f0 here, so we have 1/2 the Fourier transform of sinc function is pi, so we have pi f plus sinc squared times cosine of 2 pi fc. That's a modulation once again, so we have the transform of sinc squared is lambda f. Now when you multiply two functions again on table on page 203, that's like multiplying in time domain is convolution in f domain. So we use a convolution for our functions over here. So we have delta f minus c plus delta f plus c. Now convolution with delta is just a just a shift. Basically, it's that function but shifted. Since here we have f minus fc, so we use pi f minus c plus lambda. We can deal with the pi's first. So we have pi, or maybe we can use the lambdas anyway, same thing, f minus fc, and then you do the same thing for your f plus fc's. So you have to be a little careful here with the Fourier transform, because you have to go back and forth a little bit here. Multiplication is convolution in f domain. Multiplication in time domain is convolution in frequency domain. Okay. And when you do a modulation with cosine, then it's going to be 1/2. So you have to kind of do things a little, you have to go back and forth a little bit. So that's our frequency domain. Now for the bandwidth, here it's a DSB amplitude modulation, is double sideband modulation. So in the book on page 204 we have, let me read it for you. If m of f is equal to 0, then the frequency is greater than the bandwidth. Then the bandwidth of m of t is w, and the bandwidth of the modulated signal is 2 times the is 2 times the bandwidth. Okay, so here we have pi f minus fc is different than 0, and f minus fc is less than 1/2, so of course the bandwidth is going to be 2 times that. Okay, 2 times the frequency, and therefore that's our first condition. And for the lambda function, it's also equal to 0 for it's different than 0 for f minus fc less than 1 in this case. Okay, so therefore your bandwidth is equal to 2, right? So that's pretty much it in this case. Okay, so we have our answers, x of f and our bandwidth. Pretty straightforward here. So of course, if you have any questions, you can always put that in the comment section. Thanks.